List all points of discontinuity and describe each. As we learned in the last problem, when we talk about discontinuity, it's very much related to domain. So we need to think about the domain of this function. What is the domain of this function? And if you recall from previous classes, this is called a piecewise function. And anytime we've got a piecewise function, we need to look at each piece of the function and see what's going on there, okay? So the first part of the function is x plus 1 if x is less than or equal to 1. That means if the number x is less than or equal to 0, we're going to put it into this rule up here. If the number is greater than 0, we're going to put it into this rule here. So let's talk about, is this thing continuous? First of all, we don't have any fractions in either rule. We don't have any square roots. We don't have any natural logs. Therefore, we don't have to worry about it from that perspective. The only place we need to worry about the continuity at is at x equals 0. So that's where we're going to focus in our efforts here. So in order to do that, we need to first of all determine what is the function value. What is g of 0? Well, which rule will we use? If we put 0 into the top rule because it says x is less than or equal to 0, if we put 0 in, we get the number 1 out. So for step 1 of our rules, of our test, yes, the function is defined. Now for step 2, we need to look at the limit as x approaches 0 of the function and see what that comes out to be. Well, which rule do we use? Remember, when we're looking at the limit, we need to look at it from the left side and the right side. So let's start off by looking at it from the left side. So I'm going to put a little minus sign up here. And if we're looking at it from the left side, that means that the numbers are less than 0. So which rule do we use with the numbers that are less than 0? We use the top rule. And remember what we've talked about when we're trying to evaluate a limit. Our first thing to do is plug in the number and see what we get out. So if we plug 0 in, we get 0 plus 1, 1. So from the left side, the limit is 1. Now we need to also look at it from the right side. So that's what we'll do now. We'll take the limit as x approaches 0 from the right. Now which rule will we use here? From the right is numbers bigger than 0, so we'll use a second rule. So we're going to use x squared plus 1. Again, our first job is to plug in and see what we get out. If we plug 0 in, we get 0 squared plus 1. We get the number 1 out. So from the left, the function's approaching 1. From the right, the function's approaching 1. Therefore, the limit, we can say that the limit as x approaches 0 from the left and right, so we're not going to put anything here, of g is 1. So for step 2, the test passed. The function value exists, 1. The limit exists, 1. What's the third part of our test? Is the function value, is g of 0 equal to the limit as x approaches 0 of g? The answer is yes, it is. Therefore, the function is continuous at all points. The function is continuous at x equals 0. So we've got a continuous function here at all points. And again, we only need to look at 0 because the functions defined at other places, they don't have any fractions, so we don't have anything to worry about. So this piecewise function is continuous. We could write this down as continuous for all reals. Okay?